Couldn't be any more excited about this episode. Not because of this huge package though, but rather this one in here. Because of the battery housing built and all the electrical components installed. Final piece of the puzzle is this huge 12-volt battery. And since we've got so much stuff to do in this episode, I made a little to-do list. First, we're gonna unbox the battery and the roof box just to make sure nothing got damaged in transit. Then we gotta build a heated battery mount before installing the battery housing. Once that's in, we gotta finish up the wiring and also install the air compressor. And the most fun part at the end, we get to test all the electrical systems in the van. Besides the opening mechanism being quite flimsy, I'm pretty happy with the box. I was a bit scared about these scratches, but turns out it's just a protective cover. There are some deeper ones though that go through, so I messaged a Chinese company to hopefully get a partial refund. I went for such a big roof box because I want to put solar on, and this model has about 600 liters of volume, measures 2 meters 30 in length, and is almost a meter wide, which means I can fit a big 200 watt panel on there, but that's gonna be for a future episode. So now back to the battery. This thing is insanely heavy. It's above 50 kilos or like 110 pounds, I think. Ever since I bought the van, I've been looking for which battery to get because they are by far the single most expensive item in the van. And I think this battery turned out to be a super good value, if it works, of course. It ended up being about 750 euros, which is almost 900 bucks. And it has 640 amp hours of energy and a 250 amp BMS, which means it's not gonna be quite enough to power the inverter at full power. But I don't think it's gonna matter too much since this battery can still output more than 3 kilowatts. And with a capacity of over 8 kilowatt hours, I don't think I'm ever gonna run out of power. Also, as you can see, it's a Bluetooth battery, and that was pretty important because that gives the most accurate reading of state of charge. And it would have been cheaper to go for two 320 amp hour batteries, but apparently there are quite some issues if you have two smart batteries and then they're not rebalancing between them. That's the reason why I went for a huge one. Only problem is it's not a heated battery, so that's the reason why in the last episode we put in this little heater control, which has a little thermostat and turns on at a specified temperature and then powers these heating pads because you should never charge a lithium battery if it's below freezing. But before building the heated base, I want to try out the battery if everything works correctly, and to wake it up I think we're going to discharge it a bit and then we can try to pair it with Bluetooth. Now with power coming out of the battery, that's already the first good sign, and I just downloaded the app. It sure pops up and it's 60% charge. Then we see the different cell balances, the temperature it's reading, and then on this page we see all the errors it could give, and that should already do for unboxing and testing. So time to cross off the first thing on our list. Alright, there we go. Also, this sticker is bothering me so much, like why can't they put it on straight? Can't be that hard. So the battery is gonna sit right over here, and for fixing it to the floor I've got these two aluminum profiles and this threaded rod, and to get a more even heat distribution from these pads we're gonna use more of the leftover aluminum and cut out a little blank for under the battery. Put in the battery housing and got it lined up pretty much exactly where I want it. And also put some insulation on the inside of these angles, so that's hopefully gonna fit super snug around the battery. Base all glued in and insulated. The next layer is going to be the heated aluminum pad. So we're going to glue these 4 pads on this sheet, then use some of these solder connectors to beefing up the factory wires, and for that we've got a new package with some new cable and some super strong duct tape. just plugged in a little testing setup, and I wish I had a thermal camera because it's super cool. The aluminum conducts heat just as imagined, and even comparing straight on the heating pads and the aluminum, it's pretty much the same temperature. So I've got it running out here for like 15 minutes just to check if everything's working right and nothing's starting to smoke or whatever. But since everything's working fine, we can put it in place over here, and we're one step closer to finishing the battery mount. So the panel fits like a glove, and while we're talking about the battery heater, we've still got some unfinished business over here. Because after all, in the last episode we got the LLL message, and it turned out to be a sensor fault. So I had to get a replacement, and I didn't trust the sensor, so I ended up getting 3 of them, and hopefully one will work. That was weird. For the first time ever, it just showed a temperature. Now, I'm not sure if I should still replace it, but now it seems to work, and if I touch the temperature sensor, then the reading should quickly go up. Well, it is getting some pretty weird readings, so let's just get a new one installed. Or we can use the patio lights. That took quite a bit of figuring out until I got the temperature control working, but I got it set up in a way that if the temperature drops below 5 degrees Celsius and I've got the switch turned on, then the control unit will send power to the heating pads until the battery reaches 6 degrees Celsius, and then it turns off again. But enough talking about the electrical stuff, because we gotta get the mounts installed. I need your guys' brain power real quick, because I made a pretty embarrassing discovery, I think. So for fixing the battery, I thought I'd go with these threaded rods. But the problem with normal nuts is, if I tighten this down, then I'm pretty much just doubling down on the rivet nut, but it wouldn't actually tighten the connection. So I got some left-handed nuts, and I thought I could just put them on the bar by turning them counterclockwise. But as far as I'm concerned, I just figured out that there's no way of putting a left-handed nut on a right-handed bar. And I mean, it does kind of make sense, but at the same time, I think it doesn't. So instead, I'm just going to use some thread locker. And once I tighten the top bolt, there should be enough tension to hold everything in place. I have no clue why I thought this wouldn't be strong enough, because I can tighten this down plenty. And here's my second big brain move. I didn't take into account the bottom plate and insulation, so yeah, we gotta cut those down. The next step would be the battery box, but let's skip ahead a bit, because now without the big enclosure in our way, is a perfect time to continue with wiring, where we still need to connect the battery to the bus bar and the switch, and then work on the inverter outputs. So let's grab all the electrical stuff. So that should be all we need for the 2 big cables over there. The beefy 95 square millimeter cable, then the hydraulic crimping tool, heat gun and the heat shrink to make it look nice and tidy, and then these huge nuts. So let's do some wiring up. Temporarily fix it to the shunt, so now we can take some exact measurements and then do the same thing with the positive side. Both battery cables are done, and I'm not going to connect them to the battery quite yet, because then I couldn't get the housing installed, but also it would send power to the inverter, and I don't really want that when I'm working on it. So now onto the corner over here, and I did get another delivery. Don't mind that. So those are holders for the Wago clamps, which lets us screw them to the wall and make everything nice and tidy. Now please bear with me, but it might get a bit complicated, especially if you didn't watch any of the previous episodes, but I'll try to explain what we have to wire up. So just to give you another quick overview, here's the big battery, then we have the battery cables going to the shunt and the big bus bar. From there we have the inverter, which is gonna send 230 volt power through the enclosure to this side over here. Then let me pop that out. And that'll end up in this box. Then we have 2 more bus bars, which are going to be connected with this cable to the main bus bars over here. In total, there's 3 solar charge controllers, the DC-DC charger when I'm driving the van, and then 2 fuse boxes which are handling all the consumers, which mainly means the ceiling vents, the lights, and also the 12 volt outlets over here. Then from the 230 volt box, we have 2 outlets in here and 1 outlet on the outside. And also out here are 2 solar inputs, which feed to the solar charge controllers we saw in here. And then up on this side is the control unit, where we have the inverter control and the battery monitor from the shunt over here, switches for the ceiling vents, and then 2 more for the air horn and compressor. The compressor switch is turning on and off the relay over here, and the air horn control also goes through the big conduit into one of these 2 pipes. And then if we open the trunk, it comes out of the van over here. And then first we have the air line running from the compressor to the air horn, and this bundled up, which is turning on the solenoid valve over here. I warned you that was going to be a lot, but now let me walk you through all the unfinished job on the electrical stuff. First, we got to run some signal wire from the air horn through the conduit up in here, and that will get power from the switches through the conduit, but the negative side doesn't exist yet, so we got to wire something up for the air horn, but also the relay. And then as for the inverter, we have this little grounding pin, which should connect the metal case to the chassis of the van, and then we got to combine the ground and the neutral output from the inverter and set it up in a tidy way so that it's going to be super easy to connect all of these wires once the battery box is installed. My apologies for all of that gibberish, now let's get to work. No, I didn't film much of it because I got so annoyed. I spent the last 2.5 hours just to get the single cable through. I tried different cable sizes, the wire snake, even cut up a big conduit to get this wire out, and use my cutting board product as a lubricant because we don't have any Vaseline anymore. And eventually I had to open up the van and just cut the conduit in half and dismantle pretty much everything, but finally it's through so we can hook it up. After all that tedious electrical work, we can finally get the enclosure installed today. And to make it look nice and tidy in the end, we gotta dry fit it one last time, tape up all the edges and decide where to put the screw holes. And once that's done, I gotta give my car a quick wash because it's looking horrendous. Alright, so now it really is the last dry fit. Time has finally come for the glue up, and I've taped everything up over here and then also all the visible edges over here. And I added a little copper heatstick to the battery for the temperature probe. So please keep your fingers crossed and let's get this glued in. That was by far the most stressful glue up of the entire van build. There were just so many screws and so much sealant I had to keep tidy. I'm not super happy with the job, but after cleaning up a bit, it doesn't look too bad. And we finally got to check off the third point on our to-do list, which means onto probably my favorite part of the entire van build, hooking all the electrical stuff together. And while all of that is a bit complicated and could even be a bit dangerous, I hope with all the planning and prep we did, it should be quite a safe bet. So let's get right into it. Oh, in fact, I already started with 2 more Velcro clamps because there is no way of filming in this tight space. And I also glued on the temperature probe and a bit of insulation. So the battery heating should be done and we only need to connect this box now. pretty much everything on this side is done. And also the little box is connected and the big battery cables are on. So now it's time for all the rest coming from this side, which means the big 230 volt cable and then also the huge conduit with the many lines in there. That was another super long evening, but I'm really happy because all the electrical stuff is done. I used a ton of cable ties and wire clips to organize everything, and now it's looking nice and tidy. Also gave it a good clean because it was so dusty, especially down here. And just check out how lucky I got. This is all that's left from the 35mm cable running from this side to over here. I initially planned ordering 6 instead of 7 meters, so thankfully I didn't do that. I can't wait to finally turn the power on, but there's one more thing on our to-do list. Need to get the air compressor and replace the pliers with the XC90 connector so that it fits into this socket over here. Time has come and we can start testing the electrical system. Now I think I'm just gonna turn on stuff one by one and see if it works. So we've got the main power switch in here. Now the battery should be supplying power to all the systems. And actually the battery monitor turned on. Now Joe said the battery is completely empty because we didn't calibrate it yet. And that requires either a full discharge or charge of the battery. So we're gonna get to that in just a bit. And we don't see any lights on the fuse panel, which is good. Same thing over here. So let's turn on the lights and it already starts reading the power consumption. And then the fans should work too. Next up, the air compressor. So this switch controls the relay over there, which goes to the output for the air compressor. So it's probably gonna get quite loud. So that works as well. I don't think we're gonna test out the air horn today because it's super quiet out here. And I'm probably already annoying the neighbors with the compressor. So yeah, that has to wait for the next episode. Then back to in here, we have the light for the battery compartment and the battery heater, which shows quite a plausible reading right now. Also talking about temperatures, I added a second temperature sensor on this side of the battery, which goes to the MPPT for the solar, which is going to be permanently mounted on the roof. Then the MPPT gets power through its output, but the solar array isn't connected and also it isn't set up properly, so let's do that real quick. So with that set up, I actually want to try out the charging, and I've got the solar panel over here, which I'm going to mount on the roof box. And it might not be the wisest decision, but I just want to put it on the roof and see if it's charging. So it's a 200 watt flexible panel. It's fully in the sun now. So if we plug it in, I think we should get quite some power out of it. Let's switch the input on. We actually have a current going, 9 amps at 13 volts, so that's about 100 watts. Well, it's actually even more, it's 123. And if we check on the app, 23 watts. And then of course BougeRV also has an app, and here it also says around 126 watts. And there should be some sort of tracking how it did, and just lots of data, so yeah, that's pretty fun. I can't wait to actually get on the road and generate some more power, especially with the portable solar panels we can put in. And now we get to kind of the main point of the entire system, the big inverter. So let's see if I can put out enough power to turn on the heat gun. So first up, we're gonna turn on the inverter. And that works so far. Now it has a surge in power consumption, and it manages to get the voltage up, which doesn't look too bad. Because I'm running the ground over the chassis of the van, I just want to quickly make sure that there's no voltage on the chassis, just as a safety measure. But I mean, if there was, we're pretty much beeped. So first we got to make sure our multimeter is correct, and we've got a good reading. Then if we check over here, we're not reading anything, so that's a good sign. So let's turn on the main breaker and test it again, and we're still good. So now we can send power to both of the indoor outlets and then also the one on the outside. Well, let's hook up the heat gun, and that should pull about 2000 watts, which should be quite a good test for this. And it works. That's awesome. So let me put it on the ground and let it running. It is a bit sketchy, but I want to see the numbers on the inside. All right. So both the battery monitor and the inverter are showing about 2 kilowatts. And you can already hear the vents going off. Oh, and there's a little vent symbol over here. So that's one outlet. And let's see for the second one. That works as well. And then for the last one, that one works too. So let's turn those off again. Well, in fact, let's try out if the breakers work. That's 1. That's 2. That's 3. Perfect. Turn the lights off again. We're back to charging up to 150 watts, which is awesome from a 200 watt panel. I just found the settings menu. So it seems we can actually set our battery specs. So let's see what we get now as a reading. So it actually doesn't capture the state of charge through the voltage, but rather the amp hours, so we still need to calibrate it. And at this rate of charging, it looks like we're full in 60 hours. Now this has to have been my favorite episode by far. It's just so cool to have all the systems figured out and working together. As I said, I can't wait to go on the road with the van. We still gotta build the bed and the kitchen and then figure out the roof box situation. So subscribe if you don't want to miss that, and leave a like if you enjoyed the episode. As always, thanks for watching, happy weekend, and until next time. We forgot something.